equation as opposed to just logarithms or exponentials, which are just like what we were just doing. I don't believe there's any graphing on it. However, we get more complicated problems, such as 36 to the x plus 1 equals 6 raised to x plus 6. How do you solve this? Okay, what do you mean by common denominator? There's no denominator there. Okay, so one way of doing it is we can change this 36 into 6 squared. And note that lets us just do 2x plus 1. Okay, everybody follow how we did that? It's one of the rules of exponents you probably learned when you were in pre-algebra or algebra 1. Then what? Okay, so one of our convenient rules is this. Okay, one way, yeah, we can do log base 6 on each side. Log base 6. No, log base 6 of 6 cancels, leaving you 2x plus 1 equals, cancel here as well, giving the x plus 6. Which you can now reduce it to an algebra 1 problem. So you have 2x plus 2 equals x plus 6. So x equals 4. Now we should go back and test them and make sure they work. 4 plus 1 is 36 to the 6th power. Wait, you can't go ahead and correct it. What? Okay, it is the same number as 6 to the 10th power. Okay, so same number, therefore 4 works. Notice, if the first step here, 36 raised to x plus 1 equals 6x plus 6. We could, in the first step, instead of changing it to 6 squared, we could apply the logarithm immediately, if we wanted. Because then we could write this as log base 6 on each side. However, we still run into the problem, we need to recognize that 36 is 6 squared. So either order, it doesn't matter, but here we have to recognize we get 2 raised to this power, or 2 times that. Let's see, what's another type problem? How's that one? Easy one first here. ln x equals 5. How do you solve it? Yeah. Okay, so to cancel the natural log, the opposite operation of natural log is e to the power. So we get these cancel, leaving you x equals e to the 5th. And there's different types, it depends on how the answer is. If it just said solve, this would be the expected answer. However, if it said solve round to the nearest tenth or hundredth or whatever, you want to put that in your calculator. Does everybody know where the e button is in your calculator? So e to the 5th, if you're putting that in, next you have the yellow right here, you go e, it automatically does the exponent, put in 5, enter. Let's see, a bit more complicated. Negative 3 ln x equals 24 equals negative 24. What did you do first? Divide by negative 3, which leaves us ln x equals 8. Therefore, x equals e to the 8. Okay, so let's take a few more steps more difficult.
When you're doing the natural to find x, do you always have to put that e in there?
Well, if we want to cancel the natural log, what do you mean by put the e in there? I'm not. Like, are you saying we just leave it at 8?
Okay.
Or.
Does that have to be a step, like putting
Or are you, so could you go directly from here to here?
Yeah.
Yes, you could. This is just showing what I'm doing, the work I'm doing. Because this E and ln cancel. No, I'm raising to in a power. Let's see. How's this one? Log base 6 of x squared plus 5 equals log base 6 of 41. What are you going to do to solve? Actually, I'm going to change it instead of 41, make it 4. 41 is going to be really big. How would you solve it? Okay. Okay, you can. However, what I suggest doing is just leave it where it is and raise both sides, do 6 raised to both sides. Now, doing that, and you're going to get the same answer either way. So, these cancel, leaving you x squared plus 5 equals 4.
Okay.
But it's undefined. Okay, so we raise each power, right? Is that where you got stuck?
Yeah.
Okay, because when you have base 6, you cancel it, you 6 raised to that. Just like when we had ln, to cancel it, we do e raised to ln. They cancel, we use just what's up there.
No.
So that's the same thing we're doing here. Give you x squared plus 5 equals 4. Subtract 5. X squared equals negative 1. X equals square root of negative 1 plus or minus. And we've got a imaginary answer, so this would have no real solution. What? That's going to say no real solution. Because you can say it is plus or minus I. That's the same thing.
But what if you just put like the circle with the slash here? So you try to want I.
You would want to put no real solution, probably. If you put this, it means that there's no solution at all. However, there is a complex solution. Yes, if you don't put plus or minus, you get it wrong. The imaginary answers always come in pairs. That's what we remember from last chapter. We said imaginary answers, we always have if positive I was a solution, negative I was also a solution. So you can't just put I as a solution there. Let's see. What's this one? A bit more complex even. ln2 raised to 3x plus 4 is equal to ln3. Actually, that was what I had.
Wait, what?
So, 2 raised to 3x plus 4 is equal to 3 raised to x plus 1. Now, we can't necessarily do a log base 2 on each side, or a log base 3. So if you multiply by 2, if you multiply by 3, I don't get 6 raised to the power. What is the order of operations here say we do? We have to do this exponent first and then multiply by 3. So we're not getting 6 raised to the power. We're getting 2 raised to this times 3. You understand that? Okay. Because if we did 4 squared times 5 is not 20 squared. So, one method, okay, there are multiple methods of handling a problem like this. First of all, do you think the answer is going to be nice or not nice? Okay, probably not very nice. So, one way of handling it is taking the natural log on both sides. Okay, how does this help?
Because they both have the same base.
We do have two logarithms with the same base.
And then
What can we do with an exponent if we have a logarithm?
multiply it.
Yeah, we can pull this out and make it 3x plus 4 times natural log of 2 is equal to x plus 1 natural log of 3. Okay, now we're going to have to get all the x on one side, everything else on the other.
So
This-
subtract ln of 2.
So this is almost an algebra 1 problem. Let me show you what I mean by that. If I change this 3x plus 4 times p is equal to x plus 1 times q. Actually, it's n. No, m.
T.
T. Okay. Don't want to do n because it might confuse with ln. So how would I solve for x with this problem? Because this right here is an algebra 1 problem.
Divide by x plus 4.
Okay? We could, although it's not going to be very helpful. I'm going to distribute. So we're going to have, so should I do this one or this one?
The 3 one.
Okay, 'cause no, they're going to be treated the exact same way. So 3x ln2 plus 4 ln2 equals x ln3 plus ln3. And you have problems that look something like this in algebra 1. Okay, we want to move all the x's over, so I'm going to move this and move this one. So I'm basically swapping sides with those. So you have 3x ln2 minus x ln3 is equal to ln3 minus 4 ln2.
Are none of these terms like terms?
No, none of them are like terms. Actually, these two are like terms. Why can I say that? In a sense, they are like terms, because the only variable in them is x. And these two could be considered like terms, because they are just constants. However, they're not the same natural, they're not the same phase. We could combine them with, you have subtract outside become division inside. So I'm going to factor x out of this first one. 3 ln2 minus ln3 is equal to ln3 minus 4 ln2. So now what do I want to do to get x by itself?
Divide by 3 ln 2.
Yeah. So I'm going to get x equals ln3 minus 4 ln2 over 3 ln2 minus ln3. Now, I can combine the things on top, combine the things on the bottom, right? Using the condensed that we did. However, most of the time when you have a problem like this, it asks you, find the answer rounded to nearest 10th, or 100th, or something like that. So, could you put that in your calculator? So what would it look like if we condensed this expression?
Yeah.
Yeah, so just look at the top first. How would that condense to?
And 3 over 4 ln 2.
3 over 4 ln.
No, ln 3 over
2 to the 4th. Or if you have it here, we can move it up the inside. Yeah. You say natural log of 3 to the 16th over
natural log of 6 over 3 or 2.
where's 6 coming from?
Oh, no, 2 to the 3rd, so yeah, 8 over 1 to the 3rd. But, so is that one to your calculator?
Yeah. Well, you could put this in or this in. You get the same answer either way. We just simplified it a little bit. Anybody have it? Is this number going to be positive or negative? Okay, well, if we get this answer, is this going to be positive or negative? Log of a fraction. Or log of a fraction that's between 0 and 1. This should be a negative number, right? This is greater than 1. Okay, so what do we get? So that one was a bit trickier than the others, right? Just a little bit though.
Are we going to have ones like that on our
I believe so. No, so we don't have to use natural log. We could use any log we want, and the same rules would apply. It would just, we'd get to the end here, and we'd have like log of 3 over, log base 15 over log base 15. However, does that change anything? No. So note, if I wanted, what's another way I could write this? This.
The way it was before.
Yeah, let's leave it there. Anyway. I have another question, like e raised to 4x minus 1 equals 5. How would you solve that? Okay, take ln on both sides. They cancel here, so you get 4x minus 1 equals ln 5. Then what? We get x equals 1 plus ln 5 over 4. And note, it doesn't matter the order whether I do ln 5 plus 1 or 1 plus ln 5. I just put it that way to make sure it's clear that the 1 is not in the logarithm and you can't combine the 5 and the 1. And let's see, I have one more here. E raised to 2x plus 2e to the x equals 8. So what do you think for this one? It's not going to work as easily as you want.
You combine it?
Can you?
No.
Not easily. And you can, but not easy.
Factor out e?
Okay. Can't really do that. Yes,
You could, maybe look up changing the u.
What is this going to become then? Oh, you can do minus 8 equals 0. Because that looks a lot nicer. Remember, we did that, I think it was the last chapter or the chapter before, we did some of these problems. Now what can I do?
How does u squared equals e to 2?
So I can write this. E to the 2x is equal to e to the x to the 2. Remember, when you the rule of exponent is if you have an exponent to an exponent, you multiply the two exponents. So what do we do next down this one? Okay, how do you factor? U plus 4, u minus 2 equals 0. Then what?
U equals negative 4.
So u equals negative 4 or
2.
Okay. Now, can e to the x equal negative 4?
Yes. No. No.
Yeah, he said yes, no. Who said yes?
No.
He said no.
Yes.
Okay. Why not? Not without the base being negative. Yeah. So I could put any number of 1 up here, I'm not going to get a negative answer, so I'm going to throw that out. Which leaves me e to the x equals 2. How do I solve it? Therefore, x equals the natural log of 2. And you can plug it back in and test it. ln2. What's e to the ln of 2 times, or e to the 2 times ln 2?
84.
4. E to the ln of 2 is 2. E to the ln 2 is e, we have 2. 2 times 2 is 4 plus 4 is 8.